Hello everyone, let's talk about another hard problem on Leetcode today, maximum score words formed by letter. It says that given a list of words, list of single letters might be repeating and score of every letter, return the maximum score of any valid set of words formed by using the given letters. Word I cannot be used two or more times. It is not necessary to use all characters in letters and each letter can only be used once. Score of letters A to Z is given as score 0, score 1, and then score 25 respectively. So that means like our character set is restricted to small case letters. Let's look at the first example. So it says that we are given these four words: dog, cat, dad, and good. And then there are some letters given to us. So that means this is the supply of letters we can use to form those words. And then if we can form those words, then there is a score array given to us. So they have simplified it in the explanation. So for example, A has a score of 1, C has a score of 9, then D has a score of 5, and likewise. Then we can form multiple like subsets of these words. Like one can be like dad and good. I think the one which wins is dad and good because the score there is 23. Because when we form dad, if you see D has score of 5 and A has score of 1. So dad is 11. Similarly, let's look at good score. G has a score of 3. Then O has score of 2. So that's why it's 2 here. And then D has a score of 5. So again, it becomes 23. And note that there is also a letters array given to us. So D occurs 3 times, right? For example, so that's why we can form dead and good, because when we use dead and good, D, 3 letters of D are available. Similarly, A at least occurs once. So yes, so there are 2 A's, and we can use one of them. And then in terms of O, we are also supplied with at least 2 O's here. So given these letters, we can also form dead and dog as well. That can be one of the subsets. And the score here is 21. So if you think of it, one of the easiest solution to solve this problem is using subsets, right? Because the subsets is mentioned so many times, and it involves backtracking. We generate those valid subsets given these input supply of letters. And we calculate all the subsets, calculate all their scores, and then we can just return the maximum score. That is one approach. Another approach can be that, okay, we just keep track of the score somehow. If this problem has overlapping subproblems, then we can also use dynamic programming. But I will implement this solution in the coming days, given I have not yet introduced dynamic programming on this channel. Today, we will solve this problem with the backtracking approach. To understand this problem, I will highly recommend you to revisit the subset problem that we have covered. So this state space tree is very similar to what we did in the subsets. So at each path, we will see that can we choose this word or not. If yes, then we will go ahead and then we will calculate all the scores for that subset, and then we will return the maximum score that is possible. So initially the words given to us are dog, cat, dad, and good. So we will go in that order. And then we have the score array given to us where A is equal to 1, C is equal to 9. And similarly, I've generated this count array, which is coming from the letters. So we have 2 letters of A, 1 letter of C, 3 letters of D, 1 letter of G, and 2 letters of O. So think of it like a frequency map. And then what we will do is, like, we will at each step we will check, should we include dog or not. So answer is like dog can be formed because we have one supply, like we have 3 D's available, so we will just use one of them. Similarly, we will use one of O's and one of G's, so everything is possible. And now the updated count array becomes A is 2, C is 1, and we will also keep on updating the count array. We can take dog or we cannot take it, so then it will say empty. Then we will go to the next word, like our index becomes 1, and we can see cat. But can we take cat? And the answer is no. Why? Because there is no T at all, and that's why we cannot go with this path at all. But we can always go with the not including part, right? So our word says dog in this side, and on this side we still have the empty set. Now the index becomes 2, and we come at dad. And now we can either include that or we don't. So if we include, and by the way, with the word score for dog was 10, right? Because score of D is 5 and DOG becomes D 5 plus 2 plus 3. So that's why it's 10. Similarly, word score for dad is 11. So now we see, okay, we can actually take a dog and dad together. So our score increases to 21. Then if we don't include it, we still have dog as one of the unit in the set. And similarly, we will go this path because this was empty. If we include that, our score becomes 11 and our empty set remains empty. Now we go to good, like our index, we come to the last word. So that means we will now generate our sets. So if we look at good, our updated count does not have enough room for like DOG. All of them were missing. So we can't go ahead with good. A score from this will be dog and dad, so it will be 21. Similarly, again here, if we take dog, we still don't have enough org. If you see, this was the what is a count array after taking the dog. So A was we can clearly see G is 0 because we don't have any G remaining because we use it in the dog. And similarly, we can't use it in the good at all. Similarly, O is also 1, but we need two O's, right? D is still available, but we can't do anything there. So we can't proceed with this part, but we can still generate dog here. So then our score is 10. And similarly, in this path, we had chosen dad, but luckily here we can actually take good. So our score becomes 11 plus 12, 23. So that is one of the scores. But if we don't take good, then the score remains 11. Similarly, for the empty set, if we take good, our score becomes 12 and then 0. So if you see, the maximum of this is 23, and that is our answer. So this is the brute force approach. Now let's look at the time complexity here. At each step, we are taking like whether to include or not include the word. So that will take like 2 to the power of n, because where n is the number of words. And then we are iterating over this words array. So it will be n into 2 to the power of n. And then similarly, we are calculating the score for the word. So that will depend on L, which is like average length of the those words. So that is one thing. And also we are updating the count array, which will take 26 and into 26, but this is constant. So our time complexity will be O of n into 2 to the power of n into L. Now let's jump into the code part. The first thing I will do is I will create a frequency map. In Java, we can do it using hash map, where key will be the character and integer will be, or the value will be the integer, which is equal to number of times the character has occurred in letters. But in our case, because our characters subset is so small, it's like 26 characters. So I can just take that. So it will be count equal to new int. And then I can just take score dot length, because yeah, score has only 26 characters. I can also take 26. I mean, I'm just reusing it. And then we can just loop over the letters and then just to count ch of minus a. Why? Because it's a small case letter. So I will always, if I subtract say a from a, it will become 0. Similarly, if I subtract z from a from z, then it will become 25. So I will automatically get the index, and then I will just increment the count there. This will give us the frequency map. And now I will just start the backtracking logic, which will be very similar to the subsets problem that we saw earlier. So I will just pass the words. I will just pass the, instead of letters, now I will pass the count and just pass the score, or an initial index, or the initial word that will be processed will be 0th word. So I will just pass it as well. Now we can just start the backtracking function. So the first, again, define it here as well. So it will be word backtrack. I can actually copy paste part of it here, count and then score. And then I will also pass in the index. Then the first step we will do is like we will check if we have reached the end of the array. So if we have, then we will just return, right? And in this case, we will just return 0, because when we are out of bounds, there should not be any score, right? So we will just return 0 in that case. Now we will just generate the answer. So for the current word, what we will do is we will just start for the current word. Then we can also define a variable called is valid, and we will see why. Initially, we will just set it to true, and now we can see if we can actually use the ith word given the count array we have so far. So what I will now do is like just say, okay, count ch minus a, minus minus, because we are just using this word. And we will also increase our score for this word. So it will be again score ch minus a, right? Yeah. And if at any point our what you say count has dropped below zero, that means count of the current character has gone below zero. That means we don't have that character anymore available to form this word. So that means we cannot go with this path. So we will set is valid to false. So if count ch minus a is less than zero, that means is valid is now false. Yeah, and that's it. And now if it's valid, then we will go to the next word with the updated count array, right? That's the only difference. So this is the include path. So our answer will become backtrack, and we will again go with say like inputs like words, count, score, idx plus 1, because now we are going to the next word, and we will also add current to our answer. Only important thing is like this count is actually the updated one based on the current words usage. And in any case, we will go to the next step. That will be like a exclude step. But before that, we should actually fix the count array. So we will just do char ch, again, the same loop. So I will just copy paste this part. And only thing we will do is like instead of minus minus, we will just do plus plus. Note that I didn't break out of the loop here when the path has become invalid. And the reason for that is like we want to process the whole word and update the count array, and then we will again do the same thing here. So once we have done it, we will just do the revert operation. And now what we have to do is we have to um, go to the next step, which is the exclude path. So it will be based on our current answer. So we have to get the maximum out of it. And now we will just go to the exclude part, which is words, then count, score again, and idx plus 1. Note now the count array is the original one when we reach to this DFS tree, and that's why this word is not exclude the current word at the idx or the index is not included anymore. So that's it. And now we have it. We will just return our answer. Now let's run this code. Awesome. Now let's submit it. It beats 80%, like it's very fast. So I think it still works, but I think dynamic programming solution may be faster, but we will cover it in the coming days. I hope you like this video. If it helps you, please like and subscribe, and comment what you liked or what you didn't like and what we should do better. Thanks again. Have a nice time.